Dr. Bbosa science, kwano kwa beti science, love ya Bbosa science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A level, we teach sciences only. At O level, we teach arts and sciences. Today, we are going to study transition elements. These are metals with partially filled d orbitals. They include scandium, argon filled d1 4s2, titanium, argon filled d2 4s2, vanadium, argon filled d3 4s2. For chromium, a half filled d orbital is more stable than less than a half filled d orbital. So instead of filled d4 4s2, you have filled d5 4s1. Manganese, argon filled d5 4s2. Iron is argon filled d6 4s2. Cobalt filled d7 4s2. Nickel filled d8 4s2. Copper, a filled d orbital is more stable than less than full filled d orbital. So there's the arrangement. Instead of being filled d9 4s2, you have filled d10 4s1. Then zinc, which is the filled d10 4s2. Zinc actually is not a transition element because it has got a full d orbital. Physical properties. 1. Transition metals have high melting and boiling points due to strong metallic bonds, which involves participation of both 4s and 3d electrons. The more electrons involved in the formation of metallic bonds, the stronger the metallic bonds. The stronger the metallic bonds, the higher the melting points and boiling points. 2. Transition metals are good conductors of heat and electricity. This is due to big number of the localized electrons. Transition metals use the 4s and 3d electrons in the transmission of heat and electricity. 3. Transition metals have high densities. This is due to small atomic radii but high atomic masses. Transition elements have got high electronegativity. They strongly attract bonding electrons towards the nucleus. This reduces their atomic size, yet their atomic masses are high. 4. Paramagnetism. Transition metals are weakly attracted by a magnet due to presence of unpaired electrons. Those that are strongly attracted by a magnet, such as iron, nickel, and cobalt, are said to be ferromagnetic. 5. Formation of colored compounds. Most compounds and complexes of transition metal ions are colored. For example, iron 2 compounds are green, iron 3 compounds are brown. Reason: transition metals form colored ions because electron transition of these ions and complexes produce or absorb radiations in the visible part of the spectrum. Remember that an electron to jump from a lower energy level to a higher energy level, it absorbs energy in the form of a radiation. If the absorbed frequencies fall within the visible part of the spectrum, then it will be seen as a color. When you remove a color from the white light, then you form another color. Or when an electron jumps from a higher energy level to a lower energy level, it emits energy in the form of a radiation, and if the frequency of this radiation falls within the visible part of the spectrum, then it is observed as a color. 6. Complex ion formation. Transition metals, all their ions form many complexes. For example, iron hexasulfate 2 or nickel carbonyl. In nickel carbonyl, the atom forms are complex. In iron hexasulfate 3, iron 3 ions forms are complex with cyanide ions. A complex ion is a central cation linked to small molecules or atoms through dative bonds. 2. A dative bond is a bond formed by sharing electrons provided by one atom only. For example, a bond formed between ammonia and aluminum chloride, which we call a dative bond, is a covalent bond where the 2 electrons is shared, being contributed by nitrogen atom. Usually, a dative bond is indicated by an arrow. Factors that favor formation of complexes. 1 is the high charge density to attract the lone pair of electrons from the ligands, and 2, a vacant orbital to accommodate a lone pair of electrons. Transition metals have got high charge density to attract a lone pair of electrons from ligands. They also have vacant d orbitals to accommodate a lone pair of electrons from the ligands to form a dative bond. A coordination number, the number of ligands that form dative bonds with the central ion. For example, tetraamine copper 2 ions, the coordination number is 4. Hexaamine cobalt 2 ions, the coordination number is 6. There are 6 amine groups that form dative bonds with nickel 2 ions. Naming complexes. Ligands are named alphabetically, followed by metal and oxidation state. Amine, aqua, cyano, fluoro, bromo, and so on. For example, the name of this complex, first the ligand is amine, there are 6 amine, hexaamine, cobalt. The oxidation state of this cobalt is 2, then chloride. So the name becomes hexaamine cobalt 2 chloride. So this is one word. This one is one word.
And our next dog up in the 8-inch class is Pink, a Papillon handled by Howard Carr of East Falmouth, Massachusetts.
These Papillons in the past have been very, very good in this 8-inch class.
Well, let's see if Howard and Pink can get this party started. Got the turn there. This is a little quick burst of speed right here. Howard gets in front of Pink, makes a nice line right there. Trying to get all he can.
I think people are surprised by how quick and athletic the Papillons are.
You know, you think about the herding breeds and you think about the sporting breeds, but I'm going to tell you, these small dogs, they're athletes. And look at this dog go. You go, Pink.
Trying to beat 39.65.
Contact!
He will shatter it.
6 variable oxidation states. Most transition metals form ions with variable oxidation states, such as chromium 3 and chromium 6. This is because transition elements have many electrons in the outermost shell with almost the same energy. 8. Transition metals have high catalytic activity. Transition metals use their variable oxidation states to provide alternative mechanisms to the reaction that requires low activation energy, thus speeding up the reaction. 8. Transition metals have high catalytic property. They speed up a chemical reaction by providing alternative mechanisms that require low activation energy. For example, vanadium pentoxide is used in the contact process during the production of sulfur trioxide from sulfur dioxide in the production of sulfuric acid. A catalyst is a substance that speeds up chemical reaction without taking part in the reaction. For example, iron in the production of ammonia from nitrogen and hydrogen in the Haber process. Exercise: determine the coordination numbers in the following complexes. In this complex, the coordination number is 6. There are 4 chlorine atoms surrounding the copper ion. They can ask you the oxidation state of iron in this complex. The oxidation state of iron is X. The oxidation state of each cyanide ion is -1. There are 6. The overall charge is -4. It means that X is equal to +2. So the oxidation state here is +2. And if you are asked the oxidation state of copper, you can also call it Y. Oxidation state of chlorine ion is -1. But therefore the overall charge is -2, so we can say that Y is equal to 2. So the oxidation state of copper here is +2. Only 2. With reference to transition metals, explain what is made by the following terms. Complex ion. A complex ion is a cation bonded to small molecules called ligands through dative bonding. Transition metals are able to form complex ions because they have high charge density to attract electrons from ligands, and they have empty d orbitals to accommodate a lone pair of electrons from ligands to form dative bonds. Catalytic activity. A catalyst is a substance that speeds up chemical reaction without taking part in the reaction.
Omukyala kyakufumbira kyolya, omukyala kyakufumbira kyolya, naye lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki wangana okulya mu kyalo, lwaki oza simalako olimba, olusi wogifumbira waba kulwaza, olusi wogifumbira waba wakyamu, omulungi atanabakanyiwa n'obutayoza kiba kikyamu, entikko y'omukwano kisenge, lwaki naye lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki wangana okulya mu kyalo, ofumba okwagala lisaaki okunyuma, wange nsiba mu lisaaki, mondo okumukutandwawo, mondo okumunyima ntabuka, mondo okumuzima kuba, mondo okuwomerwa kiva ku mazzi, wetegekere muno, nfunira akaseera akamala, ozanyisa omutwe ogwanyumirwa, wagazanyisa mipiira nyumisa, zanyisa baluni, zanyisa amabeere, lusinyoka n'okuyonka nyumirwe, fayo omukwano gwagala kuyiya, ofumba ogwagala lisaaki okunyuma, wange nsiba mu lisaaki, bweruba oluganda nsobola okuwasa omukyala abawuwo, njagala omukyala abaawo, betita yombayomba, betita nyiganyiga, betita ganagana, bw'oyagala akawunga abaawo, bw'oyagala omuceere abaawo, ennyimba z'omupiira asobola, anyumisa, nyumirwa omukwano gwe, mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki mono ku muntu womala kuyomba, mono ku muntu womala kulwana, mono ku muntu wotujereka, lwaki